Today's topic is going to focus on Chapter 8, which is about ionizing and non-ionizing radiation. By the end of this chapter, I hope that you can be comfortable with these following learning objectives. Be able to define the terms ionizing and non-ionizing radiation, compare and contrast them, describe sources and types, discuss the health effects of exposure to ionizing and non-ionizing radiation, and understand major incidents in which the population either of the United States or the world was exposed to ionizing radiation. The term radiation refers to energy traveling through space. This energy is associated with very energetic particles like alpha and beta particles and gamma and X-rays. Some particles are also uncharged, and these are called neutrons. Ionizing radiation has energy to remove electrons from atoms, creating ions. This property allows it to be used to generate power in therapeutic processes like to kill cancer cells and also in many manufacturing processes. There are many man-made or anthropogenic sources of ionizing radiation. X-rays and other procedures used in medicine are one example. They're available in some consumer products. We use radioactive substances in industry. Often it has been used before in paint, for example. Nuclear power plants use radioactive substances, and nuclear weapons. There are also natural sources or non-man-made sources of ionizing radiation. Cosmic rays or radiation from outer space are one example, and there are elements formed in the Earth's crust, like uranium, which release radon gas, which is a radioactive gas, during uranium's decay. There are two types of ionizing radiation to think about. One is particulate energy. These are highly energetic protons, neutrons, and alpha and beta particles. And the other is in the form of photons, so not particles, but part of the electromagnetic spectrum. These are gamma rays or X-rays. Radioactivity is the emission of radiation from the nucleus of an unstable atom. As a result, radioactive atom is converted and decays into an atom of a different element that might or might not be radioactive. Radiation energy absorbed per unit mass of an organ or tissue often is called the absorbed dose. A dose equivalent is the absorbed dose weighted by biological effectiveness of the particles that produce ionization within the tissue. And exposure is indicated by the quantity of ionizing radiation in the air produced by an X-ray or a gamma ray. The unit is the Roentgen. There are other units commonly used, curies or rads. These are units used to measure the amount of radioactivity in a sample or absorbed dose. Rem, Roentgen equivalent in man, is a measure of radiation dose related to the biological effect. It's also a measure of dose deposited in body tissue. The unit of exposure of Roentgen, as I mentioned, is the amount from an X-ray or a gamma ray. To think about the amount of radiation exposure one receives, you need to think about the time that person is being exposed, the distance from the radioactive source, and the degree of radioactivity of that material. Some substances are higher or more energy than others. Acute health effects of ionizing radiation at high levels include tissue burns and radiation sickness, nausea, weakness, loss of hair. At low levels, we don't often see what appear to be symptoms of radiation exposure. At very high levels, it can produce fatal injury. We don't see that in environmental conditions unless there's been an intentional or accidental release at really high concentrations. Likely effects or stochastic effects, probable effects, are often DNA damage because of the ability of these particles to change atoms. Long-term exposure to low levels of radioactive materials over time is often likely to result in carcinogenesis or cancer. Natural sources of ionizing radiation, as I mentioned before, radiation from space. There's a lot of element in the Earth's crust associated with uranium that can release radiation, and radon, which is a product of uranium decay, is the second leading cause of lung cancer in the United States. It's a radioactive gas that often seeps into homes, particularly basements, exposing residents. Human or man-made sources of exposure to ionizing radiation in the environment are typically release from nuclear power plants, fallout from testing, nuclear weapons facilities that are abandoned or decommissioned and waste is stored, and human exposure through medical, X-rays, or diagnostic or therapeutic procedures. Approximately half of all sources of exposure in the U.S. result from natural sources of radiation, and the other half result from man-made sources. And about a third of these exposures are from radon or from medical procedures. Uranium, as I mentioned before, is an element in the Earth's crust. It's found in many places in North America, Africa, and Australia, and almost all animals and plants contain small amounts of uranium. There's always some background levels of radiation you might detect. Radon, on the other hand, which is a colorless, odorless gas, is produced by the decay of radium and uranium. It's classified as a Class A carcinogen, which means it's a known human carcinogen or causes cancer in humans. And long-term exposure to radon has been associated with health effects like lung cancer. This is worse in smokers, and many people in the United States are unknowingly exposed to radon through indoor air in their homes. DeKalb County in Georgia has high levels of geologic formations that may allow radon to be emitted, and the DeKalb County Board of Health has a service that allows homeowners to get their house tested for free. Radiation from other sources from outside of the Earth's atmosphere include the sun and cosmic rays from outside of the Earth's atmosphere can penetrate the body. Nuclear facilities, including places where weapons are produced, are major sources of exposure. In the late 1970s, when we were still engaged in developing lots of options for nuclear power, as well as the threat of nuclear war was still very high, 3 Mile Island in Pennsylvania had a partial meltdown of the nuclear plant, and there was some fallout and exposure. As a result, no new nuclear power plants have been built. One of the largest incidents happened within 10 years of that was a nuclear meltdown at a facility called Chernobyl in the Ukraine. What are the effects of a nuclear explosion? Of course, there's a blast, so any kind of explosion causes major damage to humans or buildings. There is an extreme amount of heat, intense light, and then the release of ionizing radiation that can cause, depending on the concentration, extreme illness or long-term health effects. People near the blast might experience burns, but there will also be a lot of fallout where in the environment, the land, the plants, the animals are now contaminated with radioactivity and may not be able to be consumed. Approximately 40% of radiation exposure can be attributed to medical procedures. Of course, X-ray is a great example of a procedure that we use to diagnose things, but results in exposure to radioactivity. We use it often in dentist's office to evaluate tooth health and root of tooth health. And you'll notice that if you are in the office, they'll ask you whether or not you are willing to have the procedure. If you're pregnant, do you have any concerns? And they'll put an apron on you so that only a small amount of your body is exposed to the X-ray. Non-ionizing radiation has energy to move atoms, but not enough to remove electrons. And we use this type of radiation in lots of ways. Sound waves are examples, visible light, and microwaves. Low frequency radiation, like radio waves. Ultraviolet is another example of non-ionizing radiation. Health effects of exposure to low frequency radiation has very limited documented health effects. There's some concerns about exposure to this type of radiation, but often difficult to document the role and impact it might have on people. Sources of exposure to extremely low frequency radiation include power poles, some wiring of buildings, some exposure through electrical appliances. Research suggests that there may be some association with cancer, but the findings aren't clear. We have seen increasing amounts of exposure to radiation through cell phones. This is a low power apparatus that has radio frequencies in the 900 to 1800 megahertz range. And of course, cell phones are so widespread that everyone receives doses of this exposure. It would be difficult to say what the health effects are, but because of the widespread use, if there was associated health effects, it could be substantial. Cell phone antennas are also an example of radio frequency exposure in this range, and many communities are concerned about cell phone towers being placed in their community. Of course, ultraviolet radiation, sun, halogen desk lamps, some lighting, lamps used for tanning beds are all good examples of sources. It comes in different wavelengths, and UVR and UVB are considered to be the wavelengths that are most harmful to human health. To help people protect themselves, the UV index has been developed and produces an estimate of exposure during the day. It has a range of intensity levels where 1 is very low and 11 is extreme. And every day you can look at the UV index and decide if you need to protect yourself by using clothing or putting on sunscreen. Concerns about effects from UV radiation: skin burns, sometimes temporary blinding, but long-term consequences, what we're most concerned about would be cancer, skin cancer, both non-melanoma and malignant melanoma, damage to the eyes, and sometimes clouding of the lenses.